Hello friends, welcome back to Max lecture series. In this series, we are trying to obtain the solution for different types of higher order differential equation. As we saw in the last lecture, higher order differential equation, if the order of the differential equation is more than 1, then we will be having some different approaches to obtain the complete solution of a equation. See here, I have written y of x, this is wrong. How can we write the complete solution? We have to observe the numerator, that is called dependent variable. We have to observe the denominator, that is called independent variable. Then the solution can be written as dependent variable is depending on independent variable x of t. That will be equal to, for higher order equation, we will be having two solutions. One is called complementary function, another one is called particular integration. In short, I am writing it directly. I told you complementary function can be directly obtained by observing or by resolving the characteristic equation from the left hand side of the differential equation. But in order to obtain the particular integration, we have to resolve both right hand side divided by some part of the left hand side. Later I will tell you what is that some part, what we have to do. But anyway, since the right hand side of this given differential equation is 0, particular integration will not exist, because in the particular integration, numerator of the particular integration is nothing but your right hand side expression. Since the right hand side is 0, so numerator of the particular integration will become obviously 0. So particular integration will not exist for the given differential equation, just remove it. Now the thing is, we will be having only complementary function. Let us continue with that. I am just cancelling it. Yes. So just wait. Let us continue with this. So for this given differential equation, we understood that we will be having only complementary function. How to obtain that? We know solution. Let us start with that. D square by dt square should be replaced by capital D square into x plus 6 times of d by dt should be replaced by capital D into x plus 9 times of x equal to 0. From this, we can rewrite this expression. See there, take dependent variable outside. It is common. Once you replace d square by dt square, d by dx by capital D square, what will happen? X will become common. So this can be written as d square plus 6 times of d plus 9 into x equal to 0. After that, if you resolve this expression, see what I told you, once you take this common term outside, then you can observe one characteristic equation. Take that characteristic equation outside, just equate it to 0. How to resolve this? We can directly say product should become 9, addition should be 6, product should be 9. So shall we put 3 here? 3 plus 3 will be giving us 6. 3 into 3 will be giving us 9. So the correspondent roots are d plus 3 into d plus 3 equal to 0. That's all. After that, what can we do? From here, I can say d equal to minus 3 and d equal to minus 3. In the last class, we saw if the roots are different, then we understood how to write down the complementary function. If the roots are same, then how to write down the complementary function? Now the question is how to write down the complementary function for this given differential equation. Do you have any idea? Complementary function can be written as, let me tell you. In the last class we saw complementary function. Step number 1. First, can I write like this? X of t, right? This is x of t. X is dependent variable, t is independent variable. X of t equal to complementary function. First step is observe how many roots are here. We have 2 roots. Then write down 2 arbitrary constant a, b. Then put addition here. Multiply it by e. Here also you have to multiply it by e undoubtedly. No doubts here. After that, if you observe in the power of e, you have to write down the root values. So here we will be having minus 3. Here also we will be having minus 3. After that, this minus 3 will be multiplied by independent variable. Here here what is the independent variable? Independent variable is t. If you observe here, independent variable is t. So it can be written as a into e power minus 3t plus b into e power minus 3t. After that, take any one variable, or you can also write down like this. Second variable, take the second variable, multiplied one more time, multiplied by, whole term will be multiplied by one independent variable t. So this is the only difference that you are observing from the last one. See, in the last class we saw when the roots are different, if you observe the final solution, when the roots are different, what we did, just we wrote the final answer. What is the final answer? We have to write down two arbitrary constant, after that they are in addition, then multiplied by exponential term e, then in the power of e we have to write down the root values, then multiply the root values by independent variable, that's all, solution will be over. But when the roots are same, repeat the same procedure, but after completing the solution, at last take any one. See, you can also multiply this one by t, or you can also multiply this one by t. But any one of this root will be completely multiplied by the independent variable once. Now the question will be arises. Let me tell you. Here you can observe only two roots are there and they are repeated. Sir, suppose given it is a third order differential equation, we have taken the example of second order differential equation. Suppose if the order is third order and we are getting three roots same, like I am getting d equal to minus 4, minus 4, minus 4. If same root is will be repeated three times, then the solution will become, see, I am writing in the same fashion, x of t equal to, first write down three arbitrary constant, a plus b plus c. After that, raise exponential everywhere. After that, go to the power of exponential, write down the independent variables. Root values, write down the root values. After that, multiply it by independent variable. Here the independent variable is t. After that, see there, start from the beginning. We are having three roots, right? Repeated roots. If you have only two roots, then what will be happening is, actually first root will be multiplied by t power 0, second root will be multiplied by t power 1, third root, if third root also same root, then that will be multiplied by t power 2. That is the actual order. Since we know t power 0 value is 1, that's why I am not considering here. I told you multiply it by just t power 1 anywhere. Suppose if three roots are repeated, then what you have to do? Multiply first one by t power 0, multiply second one by t power 1, multiply third one by t power 2 and so on. Anyway, t power 0 will become 1. So we no need to consider this one. Second root will be multiplied by second root will be multiplied by t. T is your independent variable. Third root will be multiplied by t power 2. Now tell me, suppose if 4 roots are repeated, then what will be your answer? If 4 roots are repeated, then t power 0, t power 1, t power 2, t power 3 and so on. This is how we are writing the complementary function when same roots will be appearing as your answer. Did you got it? That's all. That is the difference. Whereas when the roots are different, then there will be no point of bothering about it. Just write down the solution. Sir, here if you are facing three roots, then what will you do? Write down three arbitrary constant a plus b plus c and then multiply it by exponential e. Then we have to put anyway addition. After that, go to the numerator. Suppose if the roots are 1, 2, 3, then what you have to do? 1, 2, 3, then multiplied by corresponding independent variable. It may be x or y, whatever it is. That's all. That is going to be your solution when the roots are different. If they are same, then we need to multiply it by, what you have to do? If the roots are same, then the only thing what you have to do is observe the dependent variable multiplied, just raise starting from first one, multiplied by dependent variable power 0, dependent variable power 1, dependent variable power 2 and so on. That's all. Okay, I hope now you got the complete idea about real roots. So these are all called real roots. See, root value may be positive or negative, it may be same or distinct, it doesn't matter. But see there, I am not considering any imaginary value. Imaginary means root will be multiplied by either I or j. If your root value is not multiplied by I or j, then that is not called imaginary or complex. It will be simply called real roots only. So in the next lecture, we will be coming up with one more question. Thank you all.